Okay, let me see if I can get it to run here. Come on, clear, clear. There we go. Oops, nope, almost. There we go. So it's counting. It's going to count to 10, and then it'll do the 1 10 times, and then it'll load in the jump instruction, and the thing halts. So this is different than before. So I noticed that my instruction 3 jump instruction was completely wrong. I had to rewrite it. I'll show you that in a second. I put that in, but it didn't help. And then I thought, okay, well, let me try the really, really easy one, which is instruction 2. Instruction 2 just toggles line 11, which is one of the unused pins. So I come along, I get to instruction 2, which it's here. In fact, it's executing instruction 2 over and over and over again. It's pulsating the pin 11. So you would think, where does pin 11 go? Well, pin 11 goes into the clear of the program counter. So why doesn't it clear the program counter? So these timer chips, or counter chips, these 163 chips, are synchronous timer chips, which means you have to assert the clear pin and then pulse the clock. And I'm not pulsing the clock. The only time I'm pulsing the clock is when I do a PC increment. Well, I can't do a PC increment and a clear at the same time with the hardware that I have, so that's not going to work. And that's also why the other instruction, the number 3 instruction, also didn't work, because it was a synchronous load. I loaded the value onto the bus, but then the clock has to be asserted. So you have to pull down right and have a clock go for it to load the data. Oh, something I thought about when I originally designed that thing, and then I figured I would solve it along the way, and I guess I forgot about it, so I didn't solve it along the way. But I think what's necessary is a complete rethink of the program counter. I'm not happy with the program counter. I would like to have a asynchronous clear and an asynchronous load. Maybe search around to see if I can do that. If I can't do that, maybe I can insert a clock somehow, but it would require extra circuitry that I'm not crazy about. So anyway, that's one problem. But otherwise, everything is functioning, so I'm very happy with that. So we could build a program that did what you needed it to do, and then had a bunch of no-ops in ROM until it got to 128, and then it would roll over. Much like what we did here with every 16 instructions it rolls over. Here it would have to be every 128 instructions and roll over. Now that's not a very useful program. Definitely need to get the jump instruction fixed. The other thing that I don't like about my design right now is reset. Like I said, if you want to reset the program counter, you have to do a synchronous clear. That's not happening right now. And even if I did a program clear, I also need, I believe, to clear the instruction. Do I need that? Maybe I don't need that. Maybe if that worked, that's all I need. Because if I did clear the program counter, then the next time any instruction gets operated on, the very first instruction is take program counter and load it into the RAM address and execute the ROM. So yeah, maybe I'm okay with this. The thing that what I was thinking of was I can't clear the instruction register. It'd be nice if when you cleared the machine, you were always at instruction 00. But as it turns out, every single instruction will have the same 2 bytes of code. So it shouldn't matter which instruction you end up on. The problem right now is that if I get some random instruction, let's say FF or something, that I don't have 120 or 256 instructions loaded into this ROM yet. I only have 3 or 4. I need to burn all 128 instructions, at least with those first 2 bytes, in order for the thing to clear correctly. So I need to figure out how to do that. I'm not crazy about typing that much, but copy paste, maybe it'll be okay. But anyhow, other than some minor glitches, it actually is running program. It is taking data, taking the program counter, putting it into the address space, taking what's pointed to in address space, which is ROM, putting that into the instruction register. The instruction register is then microcoded and it executes things. It's very, very close to being a complete computer. So, yeah, I think designing a new program counter is the next task at hand. Not a small one, but definitely needs to be done. If I design a new program counter and lay that out, then I can also lay out a clock board. I can probably start working on some instructions here: a halt switch, a single step switch, maybe a clear switch. A reset switch. So that would be a nice project. But anyway, I think we're close, and it'll be very easy to add the ALU back in and have it do things. In fact, we could do that now. Like I said, we just have to put in a bunch of no ops, but we could execute programs and just have to cycle through 128 instructions, or we could just duplicate the code. So, have 5 copies or 10 copies of the code in the ROM. But we could play with it. But I really want to get it function. I'm not worried. The ALU is going to work great. That's not going to be a problem at all. Problem is kind of with the whole inner workings with the CPU, and that's the part that I started this project wanting to learn about that. I wanted to learn how to design the CPU. Definitely understood I needed things like 2-phase clocks, and yeah, so I'm pretty happy with it.
And just to show you what I ended up with in the instructions, this is instruction 2. This is the same as before. It just toggles line 11. You could either choose the from line 11 or the to line 11. I have them both pulsing. But here's instruction 3 corrected. I don't know what I was thinking before. Again, the first 2 instructions are the same. The microcodes are the same. Program counter gets put into the RAM address, and then RAM gets put into the instruction register. And then I need to point to the next place, which is going to be the jump location. So I need to increment the program counter. And then this is what I forgot. I needed to then increment the RAM address as well. I need to take that program counter and update the RAM address, and then I can take RAM and put it into the PC. So this would have executed a jump instruction if the program counter was asynchronous, which it's not. So anyway, that's what I ended up with there.